Dear students, we are proceeding with our lectures on the topic of propagation of electromagnetic waves through lines with linear parameters, and we consider now line consisting of two parts. First part is cable lines and second part is overhead line with different impedances ρ1 and ρ2, different speed of propagation of waves v1 and v2, different lengths. And such consideration we assign that source of voltage source is applied at the beginning of the first line, and the end of the second line is open circuited. So it is something like short circuited, not exactly, and it is just open circuited part of this line. And at first we considered case when this U incident wave is applied to the first line, and when this wave reaches junction between first and second wave, the so-called reflected wave appear, U reflected one, and the so-called refracted wave, which is go through the junction, appear in the second part of the life. And as we assign that own impedance of the first line is less than own impedance of the second line, we have this coefficient Qu and Qi. It's reflection coefficient. Qu will be greater than 0 and Qi will be less than 0. Therefore, here we have the same sign of the reflected wave, the same as of incident wave, so resulting wave which propagate from junction in the first line will be greater than incident wave, and therefore refracted wave, which is equal to sum of incident and reflected wave at the junction of these two lines, will be greater than incident wave. But for currents we have, as ρ1 is less than ρ2, Qi reflected coefficient will be less than 0, therefore sign of reflected wave will be opposite to the sign of incident wave, and therefore level of the total wave of current in the first line will be less than level of incident current in this line. Therefore, the same refers to refracted wave, because their sum of incident and reflected wave equal to refracted wave in the second part in the this OL overhead line. Let's consider now case when this wave will reach beginning of this cable line, which is something like short-circuited part. We can write down. Oh, sorry. It is written for, at first it is written for this second part of this overhead line, and as I have told you, here we have the same level of refracted wave and sum of reflected and reflected wave. We can use for consideration of these values, we can use this expression for refracted coefficient. We can write down that as Q here, as this pu u equal to 2 ρ2 over ρ1 plus ρ2, and pi equal to 2 ρ1 over ρ1 plus ρ2. So we write it down, and therefore from this expression we can write down connection between incident wave and refracted wave in the second line. Then let's consider, as I have told you, let's consider case when this wave will reach beginning of the first line, and this refracted wave will reach end of the second line. And for this, as we have Z1 almost equal to 0, yes, so when we substitute this in this expression for reflected coefficient, we substitute, this Z1 equal to almost equal to 0, it will be minus rho 1 over rho 2, it will be less than 0, and for current we will have expression, it will be almost 1, you see, almost minus 1, okay, and for current it will be, if Z1 tends to 0, it will be almost here it will be almost minus 1, and here it will be almost plus 1. It will be less than 0, and it will be greater than 0. So such a reflection will be reached at the moment equal to 2T1, where T1 is equal to L1 over V1. So L1 over V1 T1, moment of when wave reach junction, and plus L1 over V1 equal to 2 L1 over V1, it will be the moment when this wave is back from the junction at the beginning of this line, at the, where we have Z inner impedance of the source almost equal to 0, tends to 0. So we can, you see here we have as Q1 is less than 0, so here refracted wave will have opposite sign in comparison with incident wave, so it will be less than incident wave here, and for current it is vice versa, as as Qi is greater than 0, tends to 1, therefore reflected wave will have the same sign as incident wave, and therefore resulting wave of current will be greater than incident wave. Let's consider now what is going on in the second part of this line, in this part of the line, at the end of which we have the 2 tends to infinity. At the moment equal to L2 over V2, when this wave will reach the end of this overhead line, we will and Z2 equal to infinity, we can write down expression for reflection coefficient at the end of this open overhead line. It will be root I equal to root 2 minus rho 1 here, root 2 minus rho 1 over rho 1 plus root 2. Here we have root 2 minus rho 1 will be equal impedance of the part to which this wave is connected, minus Z2 over Z2 plus root 2. And when Z2 tends to infinity, we will have here this may be neglected, and it will be minus Z2 over plus Z2, it will be equal to minus 1, less than 0. And let's write down Qu, it will be root 2 minus rho 1 over rho 1 plus root 2. Rho 1 is equal to Z2, here ρ1 equal to ρ2 and ρ2 equal to z2. It will be z2 minus ρ2 over z2 plus ρ2. And when z2 tends to infinity, we will have here these summands may be neglected, and we will have here z2 over z2 equal to plus 1 greater than 0. So, so when this wave propagate to the end of the overhead lines, we will have Q1 will be doubled, because you see here we have coefficient, reflected coefficient, reflected coefficient equal to plus 1, the same sign. So it will be this for the second part of the line. It will be the same for voltage drop. It will be the same sign as for incident wave. So it will be the same sign. So here incident wave and reflected wave should be summed up. It will be twice, and for current we will have -1. So a sign of current will be opposite to the sign of incident wave, and they will be equal to each other. So here we will have wave of current will be twice less than those of the incident wave. So by using such an example, I have shown you how we can deal with considering electromagnetic processes at incident of DC voltage on a cascade of, here we have been considered two parts of lines with different impedances, with different wave propagation speed, and with different condition at the beginning and at the end of this line. And it should be noted that a condition of equality of voltages and currents in a junction of these two lines should be fulfilled. And when we have such a condition, z2 equal to infinity, or z1 equal to 0, we will have either twice voltage and 0 current, or vice versa. So I would like to know that you have some expression of how such processes should be considered. Bye for now.